Hello, I will give you a problem. Let us try to solve this problem. Use Gauss law to derive an expression for the electric field between two uniformly charged parallel sheets with surface charge densities sigma and minus sigma respectively. Sigma and minus sigma, plus sigma and minus sigma respectively. Use Gauss law to derive an expression for the electric field between two uniformly charged parallel sheets with surface charge density sigma and minus sigma respectively. So given are two plane sheets and they are placed parallel to each other with the surface charge densities plus sigma and minus sigma. I'll write solution. So two parallel plane sheets are given. So one has a charge of plus sigma, the other one as minus sigma. One is plus sigma, the other one is minus sigma. Plus and minus. So we will consider two uniformly charged parallel sheets carrying charge densities plus sigma and minus sigma. We need to find out the electric field between, so at somewhere here between the two plates. So let us say we want to find out electric field at point P, which is in between the two sheets. So we'll write here, let us consider two uniformly charged large parallel sheet carrying charge densities plus sigma and minus sigma sigma and minus sigma respectively are separated by a small distance from each other. And in the last class we have found the electric field due to a uniformly charged plane sheet. So by Gauss law we got it as the electric field at any point P, which is at a distance say some r from the uniformly charged uniformly charged plane sheet, is given by sigma by 2 epsilon naught. So due to one sheet we know, now we need to calculate due to both the sheets. So by Gauss law we have proved the electric field due to a uniformly charged infinite plane sheet is given by, we have proved that electric field due to uniformly charged infinite plane sheet is given by E equal to sigma by 2 epsilon naught. So this we have proved. And this electric field is directed normally outward from the plane sheet if it is positive charge, and is directed inward if it is negative. So the direction is directed normally outward from the plane sheet if the nature of charge on sheet is positive. And directed normally inward if the nature of the charge is negative. So now at this point P, so due to the plane shift on the left hand side, that is it has a charge of plus sigma, density is plus sigma, so it is positive charge, so the electric field due to this will be directed away from it. So if we mark the electric field due to the first sheet, it will be going away from it. So let me say this is due to the left sheet is E1, and the right side sheet is positively charged, so the field is inward, so the E2 will be due to the plate on the right side which is negatively charged. So in this case both E1 and E2 are in the same direction. Therefore we can write electric field intensity at point P is E1 equal to sigma by 2 epsilon naught due to positive plate. So we can write here this is due to positive plate. Similarly, E2 is sigma by 2 epsilon naught due to negative plate. And now we know both E1 and E2 are in the same direction, so vectorially we can add the both together. So total net field at phi is equal to E1 plus E2. It's equal to sigma by 2 epsilon naught plus sigma by 2 epsilon naught, so which is equal to sigma by epsilon naught. So the uniform electric field is produced between the two infinite parallel plane sheet of charge which is directed from positive plate to negative plate. Sigma by epsilon naught is the electric field. So when we have two infinite plate placed parallel to each other, a uniform electric field is developed between them. So you can write a note here. A uniform electric field is produced between the two infinite parallel plane sheet. A uniform electric field is produced between the two infinite parallel plane sheet and the field is directed from positive plate to negative plate. So P can be anywhere, but the value is equal to sigma by epsilon naught, and the direction is from positive to negative plate.